All right, this is the last lesson of Unit 9, which is solving quadratic problems involving objects that are thrown under the force of gravity. So what happens when you throw objects? Well, they're going to go faster, right? So our equation from yesterday needs to account for the speed, which is more powerful than just the pull of gravity. So we're going to call this new variable initial velocity. Initial, by the way, means like starting. So what is the starting velocity? The equation we'll use is a equals negative 16t squared plus vt plus h. A still stands for the altitude, and it's dependent on how long it's been in the air, so that's time. Negative 16t squared, this still represents the distance traveled. And this is still distance traveled just under the force of gravity. So this is just the pull of gravity. Now we need to add in the velocity. How much time is added because of velocity? So this is initial velocity. And then h still stands for initial height. So let's do these three scenarios. We're just going to write the equation. That's all we're going to do. So if you were to drop a rock off the top of a 200-foot building, well, the 200-foot building, this is your initial height. So initial height is 200. You're also dropping a rock off of a building. So if you're dropping a rock, that means that the initial velocity is actually 0. Initial velocity is 0. And it's 0 because if you're just dropping it, you're not throwing it, you're not like putting any extra force behind it, you're just dropping it. So that means the initial velocity is 0. So we're going to substitute 200 in for h and 0 in for v. So our equation will be the altitude equals negative 16t squared plus 0t plus 200. The 0t kind of goes away, and this simplifies to a equals negative 16t squared plus 200. All right, part B. You throw a rock straight up with an initial velocity of 40 feet per second from the top of a 200-foot building. So what I have it in yellow, this all has to do with the initial velocity. So the initial velocity, it's going straight up, so it's going to be positive at a speed of 40. The 200-foot building, that's referring to the initial height, which is 200. So now our equation will be a equals negative 16t squared plus vt, which is 40t, plus h, which is 200. Lastly, you throw a rock straight down. So our initial velocity is going to be negative with an initial velocity of 40 feet per second, standing from the top of a 200-foot building. So straight down, that's referring to the initial velocity. What is our starting speed? So if we're throwing it down, it'll be negative 40 feet per second. And then on top of a 200-foot building, that'll be our height. So a equals negative 16t squared minus 40t, again, because we're throwing it straight down, plus 200. So with all that being said, you have to read a lot, and you have to know what these things mean. So we're going to review a couple inferences that you'll make depending on the problem. So if a ball is dropped, this means that the initial velocity is 0, okay? Because if you're dropping it, you don't have any force behind it. If a ball is thrown straight down, that means that the initial velocity is negative because it's going to take less time, so you're subtracting the time because of the velocity. If a ball is thrown straight up, then the initial velocity is positive because you're adding time. If a ball is dropped again, its velocity is 0. Sorry, repeat. If you're standing on top of something, that means that you have an initial height, right? So you'll have h equals a number. However, if you're standing on the ground, right? So if you're standing on the ground, the initial height's going to be 0, right? Because you're not on top of anything, you're on the ground. Lastly, if you want to know how long it takes to hit the ground, this means that you're solving for time, but it also means that your altitude is 0. Because if it's hitting the ground, then A will equal 0. So with that being said, let's do 2 examples together. First, we have to define our variables, then we can substitute into this equation. I'm going to always highlight something that has to do with velocity in yellow, something that has to do with height in green, and then my altitude, we'll make it in pink. Okay, so here we go. Thomas the gorilla became enraged. He uprooted a tree and threw it directly up. Directly up refers to velocity, with an initial velocity of 128 feet per second. So that's my velocity. How long will it take for the tree to hit the ground? So if it's going to hit the ground, that means that the altitude is 0. So we know the altitude is 0 because it's going to hit the ground. We know that the initial velocity is positive because it's going up, 128. Notice I didn't highlight anything green. So I have to think about what is my initial height. Well, Thomas the gorilla is standing next to a tree. A tree is found on the ground. So our initial height is actually 0. Substitute everything in. 0 equals negative 16t squared plus 128t plus 0, which simplifies to negative 16t squared plus 128t. So because there are 2 variables, I am going to have to factor. So I'm going to go ahead and factor out a GCF. The GCF will have a t in it. I also need to factor out the negative. And now I need to figure out what is the GCF. Well, I'm going to go through the factors of 16. So they are both divisible by 2. 16 is divisible by 4. 128 is also divisible by 4. It's divisible by 8. 128 is also divisible by 8. Divisible by 16. This is also divisible by 16. So I'm going to go ahead and factor out a 16t. So this is equal to negative 16t parentheses t minus 128 divided by 16. I believe that's 16 times 4 is 64. 16 times 8 is 128. So yeah. Set each of the factors equal to 0. Divide both signs by negative 16. You get t to equal 0. Add 8. You get t to equal 8. So what this means is at 0 seconds, the tree is on the ground. Tree is on the ground, which makes complete sense since if the tree is starting on the ground, then at time 0 it better still be on the ground. But what we're looking for is how long will it take for it to hit the ground. And so it's going to take 8 seconds. So after 8 seconds, the tree will hit the ground. All right. Number 2, I'm going to do the same highlighting. Let me see if I can leave that. No. All right. So from the edge of a 160-foot cliff, this is an initial height. That's how high he is starting. Peyton throws his math binder straight down. That's velocity, with an initial velocity of 48 feet per second. When will his binder hit the water? So if it's hitting the water, then that means altitude is 0. So this is our initial height is 160. We know that it's going straight down, so the velocity is negative at 48 feet per second. And then lastly, if it hits the water, then we know the altitude is 0. So 0 equals negative 16t squared plus vt, so minus 48t, plus the height, 160. I need to factor out a GCF. I also need to factor out a negative. So this is divisible by 16, and this is also divisible by 16. So I'm going to divide all of these by 16. So that's negative 16 t squared plus 3t minus 10. Factor. Two numbers that multiply together get negative 10. Combine to give me a positive 3, positive 5, negative 2. Set each factor equal to 0. You should be getting really good at this. Subtract 5. T equals negative 5. Add 2. T equals positive 2. So at negative 5 seconds, the tree hit the water, or the binder. That doesn't make sense. And at 2 seconds, the binder hits the water. So after 2 seconds, the binder hits the water.